Picture this. It's the middle of the day, your app is humming along, and then your AI provider returns an error, or simply times out. Every feature that depends on it freezes at once. If you call a single model directly, one outage is all it takes to break your product. In this tutorial we fix that for good. We'll build a fallback chain that tries your best model first, quietly falls back to a second provider when it fails, and finally drops to a local model that runs on your own machine. Timeouts, retries, and a hard spending cap are baked in from the start. Let's build it. Here's what we're building. A single function you call instead of any one provider. Behind it sits a chain of models, tried in order, so a failure anywhere just moves on to the next option instead of crashing your app. We'll wrap 3 very different providers behind one clean interface, add a timeout to every call so nothing hangs forever, retry the flaky failures, and track every cent so a runaway loop can't drain your budget. By the end you'll have a small, dependable module you can drop into any project this afternoon. Let's look at the finished picture first, so every step has a place to land. You'll end up with one call function that hides all the messy provider details behind it. That function talks to a primary cloud model, and falls back automatically to a second provider, and then to a local model, if it has to. Every single call gets a timeout, so one slow provider can never freeze your whole request. Temporary errors are retried with a short, growing delay. And a cost tracker adds up every request, refusing to spend past a cap you set. 5 ideas, and each one is only a few lines of code. Here's the flow, and it reads left to right. A prompt comes in. We send it to the primary model, the best and usually most expensive one. If that succeeds, we're done and nothing else runs. But if it errors, or times out, we fall through to a second cloud provider, using a cheaper or simply different model. And if that also fails, we drop to a local model running on your own hardware, which keeps working even with no internet at all. Whatever comes back is validated before we hand it to the caller. The key idea, each stage only runs if the one before it failed, so healthy requests stay fast and cheap. You'll need a few things ready. Python, version 3.10 or newer. An API key for your primary provider, whichever one you prefer. A key for OpenRouter, which gives you one endpoint in front of many models and makes a great second layer. Ollama installed locally, so you have a model that runs on your own machine as the last resort. And the requests library for talking HTTP. Keep your keys in environment variables, never in the code itself. That's the whole setup, and the local piece means part of this chain keeps working even when you're completely offline. Step 1, install the tools. We only need the requests library for the cloud calls, so pip install requests. Then install Ollama, which runs open models locally with a single command, and pull one small model to act as your offline fallback. I'm using a general purpose 8 billion parameter model here, which is small enough to run on a normal laptop but capable enough to answer when the cloud is down. Once that pull finishes, you have a complete local model sitting ready. That's the entire toolchain for this project. Step 2 is the most important design decision in the whole tutorial. Before we write a single provider, we agree on one shape they all share. Every provider will be a function that takes a prompt and returns a reply, a tiny record holding the answer text, the name of the provider that produced it, and what that call cost. If a provider fails, it raises an error instead of returning. That's the contract. Because every provider looks identical from the outside, the chain that calls them doesn't need to know or care which one it's talking to. This single convention is what makes everything after it simple. Step 3, our first real provider. We post the prompt to the primary model's endpoint, reading the API key from an environment variable so no secret ever touches the code. Notice the timeout argument passed straight into the request. That's not optional. Without it, a stalled provider can hang your call forever, and one hung call can pile up until your whole service stops responding. We call raise for status, which turns any error response into a raised exception, exactly matching our contract. Then we package the answer into a reply. Every other provider we write will follow this same shape. Step 4, the second layer. OpenRouter sits in front of many models behind one endpoint, which makes it an ideal fallback, because when your primary provider has an outage, OpenRouter is a completely separate company and network that is very unlikely to be down at the same moment. The code looks almost identical to the primary, on purpose. Same timeout, same raise on error, same reply coming back. Here you'd usually pick a cheaper or faster model than your primary, since this path only runs when something has already gone wrong and you mostly want a working answer. Independence is the whole point. A good fallback shares nothing with the thing it's backing up. Step 5. The final safety net. Ollama exposes a local generate endpoint on your own machine, so this provider talks to a model running right there, with no internet involved. Same shape as always, a timeout, a raise on failure, a reply on success. And notice the cost is 0, because a local model is free to run once it's downloaded. This is what makes the chain truly dependable. Even if every cloud provider on Earth went dark at once, this last layer still answers. It may be slower or a little less polished, but a working reply always beats an error page in front of your user. Step 6. Let's make timeouts deliberate. We give each provider its own time budget in seconds, rather than one number for all of them. The primary should be fast, so we keep it tight. The cloud fallback gets a little more breathing room. And the local model, which may be slower on modest hardware, gets the most generous allowance of all. The rule to remember is that a call which hangs is worse than a call which fails cleanly, because a clean failure lets the chain move on immediately, while a hang holds everything hostage. Tuned timeouts turn slowness into a fast, recoverable failure. Step 7. Retries, but only the smart kind. Many failures are temporary, a brief network blip, or a provider that's momentarily overloaded. So before we give up on a provider and fall through to the next one, we try it one more time, waiting a moment in between. That wait doubles each attempt, a pattern called exponential backoff, which avoids hammering a service that's already struggling. Keep the number of tries small, just 1 or 2, because if a provider is genuinely down, you want to reach your fallback quickly, not sit here retrying a dead endpoint. Retry the flaky, but never the hopeless. Step 8, and now everything clicks together. We list our providers in priority order, best first, last resort last. The call function walks that list, trying each provider, with retries and its own timeout. The moment one succeeds, we return its reply and stop. If a provider fails even after retrying, we simply continue to the next one in the chain. Only if every provider fails, cloud and local alike, do we finally raise an error. This is the entire fallback engine, in about 10 lines. Your whole application now calls this one function and never has to think about providers again. Before we automate this, a few words on doing it responsibly, because a resilient system that misbehaves is still a problem. Keep every API key in an environment variable or a secrets manager, never hard-coded and never committed. Respect each provider's rate limits and terms of service. A fallback chain should be polite, not a way to hammer around limits. Log which provider actually answered each request, so when something is off you can see it instantly. If you notice the chain dropping to the local model often, treat that as an alarm that your primary is unhealthy. And always test each provider by itself before wiring them together. Step 9. Guard the budget and put the whole thing on autopilot. Because every reply already carries its cost, we keep a running monthly total and simply refuse to begin a call once we cross a cap you set. That one check is what stands between you and a surprise bill from some accidental loop. Then schedule a small daily health check that sends one cheap prompt through each provider on its own and reports which are alive. A single cron line at 8 each morning is enough. On a server, a systemd timer is even better because it survives reboots and logs cleanly. Now the chain not only heals itself, it tells you when a layer needs attention. Let's recap the whole system in one breath. Every provider hides behind one shared shape, so a single call function is all your app ever touches. That function tries your primary model, then a cloud fallback, then a local model that works even offline. Each call has its own timeout and a couple of quick retries, so slowness and blips turn into fast, recoverable failures. A cost cap adds up every request and stops you from overspending. And a daily health check keeps an eye on the whole chain. That's a genuinely dependable AI layer. In a couple hundred lines you can build today. That's the complete fallback chain, start to finish. The full code and the scene spec are linked in the description, so you can clone it and make your own AI layer outage proof today. If this was useful, subscribe, because the next episode builds a self-healing web scraper that uses a language model to rewrite its own selectors when a page changes. Thanks for watching, and I'll see you in the next one.